Good afternoon, everyone. And I should say good morning, or for those of us in other parts of Australia as well. So thank you for joining us for our Earth Science Day Teacher Professional Development and for joining us for any of the other sessions you might have been part of during the program today. We have covered a lot of information and a lot of ground, and it's really great that we're finishing off with some opportunities to learn about more resources and more organisations that can help you on your journey of earth science, whether you are a parent, a teacher, or even a student that wants to find out more. So I'll hand you over now to Emily and Dominic from Geoscience Australia that will kick off our program this afternoon.
Thank you very much, Karen. Hello, everyone. Happy Earth Science Week. As Karen just said, my name is Dominic and this is Emily here. We work in the Education Outreach team. We're coming to you from Ngunnawal and Ngambri country in Canberra. And before we get into what we're doing this afternoon, sharing some wonderful resources across lots of different organisations, I would just like us all to take a moment and to recognise and remember that science and earth science is a very ancient thing here. It's been happening for thousands and thousands of years, and all that we do is just continue, all of us collectively, continue a very ancient practice of science and communicating that science, telling stories and sharing information. So thank you for joining us for this teacher professional development session. We have organised some major players in the earth science education sphere all in one space for you this afternoon to share with you some of their resources, to have a bit of fun, and to tell you a little bit about what they do and what they can offer you. And also, quite importantly, provide you with the opportunity to ask any questions of us and everybody in this room. So in the digital room, we do have Joe from AusEarthEd. We will have Jacoby from Core Learning at some stage. And we have Malta from the Teacher Earth Science Education Program as well. And right next to me, we've got Emily from Geoscience Australia. So as Karen said, whether you're a teacher, an educator, a parent, a guardian, whoever you are, even if you're a student in here, hello, welcome. Our overarching aim for this session is to expose you to some great resources and activities from all of us and introduce you to the people who dedicate their time and their passion to supporting you in the classroom. Everybody here does something unique in earth science education, but together we make up a very nice, cohesive education ecosystem that is very, very likely to have something to offer you in terms of content, resources, services, or professional development. So without further ado, we're going to kick it off, and I'm going to disappear off to the side of the camera, and I'm going to hand over to Emily to show you a new and electrifying resource that we have developed.
Thank you so much, Dom, and welcome everyone. As mentioned, we're both from Geoscience Australia and the Education and Outreach team. A very small part of the work from Geoscience Australia is education and outreach. We cover many, many different areas of geoscience. We have members working on resources and groundwater resources, a lot of work with community safety, so looking at monitoring for earthquakes and other geohazards around the country, and also a lot of work in space, so satellites, using satellites to look back at the Earth and see how the surfaces has changed over time, and also working with the GPS networking, getting really accurate positioning. But if you were to come and visit us at Geoscience Australia, we're located in Canberra. And as you can see from some of these pictures, we have the National Mineral and Fossil Collection on display. We have a piece of the moon that you can come and touch. And we also have our hands-on education centre. And so some of the work that we do, our team here, our main role is to help empower educators just like yourself and ones all across the country to confidently deliver earth science information into the classroom, and so that you feel excited to deliver that content and also engage your students. So we do that in quite a few different ways. We have a wide range of different educational resources. We run teacher professional learning sessions just like the one today. And we also offer some facilitated student visits to our education centre here in Canberra. But we thought today, rather than giving you a whoop around of all of the different resources we have, is to actually show you a new resource that we recently published. And so this resource is all about how you, or maybe even your students, can generate electricity. So to generate electricity, you're going to need to build a generator. Now, this might seem a bit complicated, but you only need a few things to build a generator. The two most important things that you'll need to do that, one of them are some copper wires. The most important thing is that you have one continuous piece of copper, and you'll probably need at least 15 meters. The second is a strong magnet. In this case, we have a neodymium magnet here. We have two magnets attached in this example for this demonstration, but you'll only need to use at least one of them. Now, you need some materials to hold your generator together. Here we have a very sophisticated cardboard tube. This is just from the middle of an aluminium foil roll or something like a paper towel roll. And then you'll need some blue tack, some sandpaper, and then something to actually illustrate that you're having an electrical current. So something as simple as a little LED too. So we'll cut over to the camera here, and Dom is going to help facilitate and show how we can build our generator. And so the first thing that you'll need to do, if you have a tube that is around 30 centimeters, is you want to attach some of your copper wire, and you want to start that at least halfway down the tube or a little bit further. And you can just use a little bit of blue tack to help you stabilize that piece of copper. And you want to start wrapping that copper wire around the tube, keeping it nice and tight together. And as you can see there, Dom has a little bit of copper wire that's attached at the end. You want to make sure you leave a little bit there so that you can connect it to the LED. Now, the most time-consuming part of this is needing to wrap the copper wire 200 times around the paper towel roll, but luckily we have prepared one earlier. And so what you can see here is our completed generator. So we have all of those copper wires, that copper wire coiled around 4 centimeters. And then we have wrapped the ends of those copper wires around an LED. Now, you might be wondering why we needed the sandpaper. This type of copper wire has an enamel coating, and so it's really important that you remove the enamel coating for the section of the copper wire that you attach to the LED. So you want to do that so that we can have a closed circuit between the copper and our LED. But that's it. And now it's time to generate some electricity. And so this will happen quite quickly. Our LED will light up. So I'll do it a few times in case you miss it. But this is something that you can build and test out yourself. So you just want to hold your generator up like this. Here I have our neodymium magnet. And in a moment, I will drop our magnet through and we can watch the light. All right, 3, 2, 1. Do it one more time. Here, 2, 1. Oh, there we go. That seemed to work a little bit better. I'll just do it one more time. 3, 2, 1. There we go. So this is a very simple generator that you can make. And now we can actually take a look at the science behind what is happening. I'm by no means a physicist, but what we're looking at right now is some key fundamental physics principles. So Faraday's law of electromagnetic induction. So Faraday's law states that a change in magnetic field, such as that magnet falling through our tube, induces an electrical current in the conductor. And our conductive material in this case are our copper wires. The induced electrical current in the copper wire to the electrical energy then lights up our LED as the magnet moves past. So it's a really simple concept, but you don't have to stop there. And this is where you as the teacher and the experts can take this inquiry any direction you want, depending on the year level that you're teaching or maybe the subject that you want to use this demonstration with. You could explore what happens if you change the type of conductive material. What if you were to use aluminium wires compared to copper? How would that affect, I guess, the ability and the light strength of the LED? You could look at using a longer tube, connecting multiple different copper wires to see if the speed of the magnet will change the strength of the electrical current. And then maybe you could think about making a different style of generator rather than the magnet physically falling down through the tube. You could think about trying to spin the magnet or the copper, thinking about a turbine system. And so depending on your age group, if you have an older age group, you can start to talk about, well, how do we actually power the world? What are some of these energy resources? Things like coal, wind, hydro, all of these different resources are used to actually just spin magnets and copper, because that's the fundamental principle around generating electricity. And you can use all different resources that come from the earth to actually power that. And then we have some nice photos of neodymium ore and copper ore, that starting raw material that you refine those products from. And if you are interested, here are just some of the curriculum links, mostly around physics, some there in earth environmental science, and also senior physics. But all of this is ready to go if you would like to head to our website and download it. And lots of resources are there. You can search by subject, age group, topic, and resource. So we would love to hear from you. And that brings us to our final slide. Thank you so much for joining in this discussion today. If you have used any of our products in the past or really want a specific resource, please reach out to us. We've just started a survey where you can give us feedback about all of our resources and let us know what you would like to see more of. And we also have a newsletter that goes out around 4 times a year. So if you'd like to subscribe to that, all that information is there. But thank you so much. And now I will hand it back over to Dom.
Thank you very much, Emily. I'm just voice of Godding over this, so I don't have to move around too much. But we're going to keep the momentum going, and I'm going to pass over to Joe from AusEarthEd. So please take it away, Joe.
And this is where I do the awkward, just checking my screen is behaving. Screen share tick. Awesome. Thank you. It's always the fun of webinars. So thank you so much to the Geoscience Australia team for having me, and for Virtual Excursions for hosting this. I'm really super happy and proud to be part of this. I'm coming to you from Wajak Noongar country in Perth, Western Australia, and so pleased to share. So I guess a little bit of a background. We've been working in Western Australia. We formed in 2003 and really got stuck in and started working with schools in 2005. So a lot of people that have taught in WA or still teach in WA still go to call us Earth Science WA, which I totally get. Even I do. I was one of those teachers. But we are actually working under the name Australian Earth Science Education, and I will explain why in a second. So I've got a few things to share with you. So what do we do? Effectively, just, as Dom said, lots of similar things in the ecosystem. We all really love our earth science. We're passionate about it, about the opportunities for students, how exciting it is, how important it is globally in so many different ways. So it's about really supporting teachers in these endeavours to excite their students, to impassion them, increasing interest and just really making it, well, the wonderful subject that it is. There's not many students that don't really get in and engage with earth and space science and earth and environmental science once we get right into the real world hands-on side of things. So we offer a lot of free teaching resources, a big suite, all the way from foundation. I'll remind myself not to say kindy, I'm such a West Aussie. Foundation to year 12. We, in our areas of operation, which I'll show you soon, we offer hands-on incursions. So we go into classrooms, and I know I've got one day coming up of 6 classes in a row, back-to-back rock ID, and bring it on, what fun. And we also offer educator professional development, mentoring, particularly in the Year 11 and 12 space. We really work side by side with teachers to support and help them. We do lots of events. I've got the Perth Gem and Mineral Show coming up soon, which is going to be fun. Field trips for Year 11s and 12s. And yes, I've got my first revision webinar for Year 12s this afternoon. So it's a day full of webinars. Yeah, so basically, me not colouring in my slides, I wanted to follow the theme again. Again, we have lots of resources. I don't want to exhaust it. Jump on the website, have a go. But we're looking at energy resources for future as the Earth Science Week theme. So I'm so glad that I've come at it from a different angle. And I wanted to explore, energy resource, emerging energy resource, one that's got some real technical difficulties but really interesting, and that's hydrogen. So we're going to play the crossover space between earth and space science and chemical sciences mostly here. And I guess this gives you a view into one of the ethoses of our organisation. A lot of us have been teachers, worked in under-resourced schools, regional remote schools, is just really easy to resource, simple stuff. So stuff that might equally come out of the kitchen as the science lab. So that's what you'll find as a common theme through our resources. And so I wanted to showcase this one. Just as a heads up, I've chopped up one of our staff training videos, but I will show you the activity it actually comes from at the end. So we're using the principles of hydrolysis. And so we're generating hydrogen from oxygen, basically, just splitting up from water, just splitting it up. And it's as simple as this. And look, we've got a beaker, good old kitchen counter stuff, but it could be a cup. So basically, all you need to do is load up your bicarb into your water until I sort of get it to a pretty close to saturation point. And that's going to be your medium, just to give you your electrolytes. It's as simple as some just push pins. Just make sure they're not weirdly plastic coated or anything. Some nice metal push pins. You're going to push them into, I know they're rare as hen's teeth, takeaway container. I recommend some tape so it doesn't crack. You're then going to pop some plastic pipettes. We're moving really fast here. Plastic pipettes into to fill them up. Basically, you're using the plasticine to chop your container up so that it's level with your battery, and so that you basically want your pins sitting directly over. So that's probably the fiddly bit about this, is just getting your pins directly over your battery terminals, and you will very rapidly see hydrogen and oxygen being generated. And one of the really cool things about this, super simple, we've done this with lots of different groups, and then we actually explore the colours of hydrogen, the different types. Obviously this is not green hydrogen because we're using a battery to generate it. I've seen people that have done it, hooked up to little solar panel kits outside and actually genuinely gone ahead and created green hydrogen. I guess what we wanted to show is that, some of these really great hands-on experiments can be really simple materials, and you can get some good stuff going. Students very quickly work out which terminal is producing hydrogen and oxygen, because you get effectively double the volume in the top of your pipette. And you really start to see some corrosion on the oxygen side pretty quickly too. So there's lots of examples. If you're feeling very coordinated, you can actually gather enough hydrogen in. We've got the instructions for it, to do a little pop test as well to prove that you've got hydrogen. And then a really good extension experiment is to look at if we modify the volumes of bicarbonate in a known volume of water, so we're actually changing sort of the electrolytes in there, does that change the volume of hydrogen generation? So it's either a bit of a demo of how hydrolysis happens in hydrogen generation, or you can go right into a quite controlled investigation, where you might stagger the amount of bicarbonate to see the result. I guess that gives you a little bit of a window. This is one of our WASP activities, so one of our programs, and it is actually part of currently year 10, going to get little modified backwards a little bit with some of the changes that are happening in curriculum, but it's one of our STEM projects, and it's one of the activities that can be done under there. So that's free to access and use. I guess a little bit more of a sort of overview. Like I said, we've been working in WA since 2005, 6, really in schools. And then, of all years, in 2020, we grew our operations into New South Wales and the NT. That was great timing to come in and help people out. And I've been with the organisation quite a long time, and I was super proud. This end of last year, we ticked over 150,000 students engaged. So that's face to face in incursions and field trips, etc. So we're super happy and lucky to work with so many educators and so many students. We get out in the field quite a lot. One of my favourite things to do with year 11s and 12s, and continue to see that really rigorous online engagement as well. To answer their question, I'm sure is on there. Our resources are obviously freely accessible to, well, effectively anyone in the world, but relevant to Australia particularly. As far as on the ground staff, we've got a couple of staff in Western Australia. So we offer kindergarten to year 12 incursions, teacher PD, etc. In Northern Territory, we've got a fabulous staff member in the NT. So also offering primary and secondary incursions and teacher PD. And in New South Wales, we have a fantastic experienced earth and environmental science educator that supports year 11s and 12s. So with things like core library excursions, incursions, teacher PD, mentoring, all sorts of things. So yeah, that's sort of our footprint at this stage. And like I said, all of it's really accessible. We are at the moment reworking all of our resources. Obviously, there's been some curriculum changes in the last few years, bringing it back onto our main AusEarthEd.com.au website. So please use that as your main port of entry going forward, and it will pop up a little map asking where you are, not to be annoying, but just so that if you're in WA or New South Wales or NT, it actually shows you pretty quickly incursion and PD offerings as well. So yeah, basically that's us in a little quick nutshell, and all of that is possible thank you to a range of wonderful supporters. Some of them have been with us right from the get-go that are really keen to support earth science education across as much of our lovely nation as possible. And yes, feel free to get in touch. So ausearthed.com.au, or feel free to contact me directly, and happy to answer questions, connect dots, etc., etc. Thank you so much. I'm going to stop and I'm going to hand back over to John.
Thank you very much, Jo. It's great to see the use of simple and accessible materials to lower the barrier to entry to all of this wonderful science and to make it super, super accessible. I think it's a really important way of getting these demonstrations and these conversations into the classroom as well. So excellent. I am going to pass over to Malta from TESEP now. So Malta, please take it away.
Thank you, everyone. Let me just load up my slide. So yes, thank you for inviting us. Thank you, Dom and Emily, and it's a pleasure to be here to celebrate Science Week. And I'm coming from the Durrow country in near Sydney, or actually in sort of Western Sydney, and yeah, and here it's quite warm at the moment. So yeah, it's quite lovely weather. So I'm from TESEP, and today I'm just going to sort of tell you what we do and what sort of resources we offer, particularly the critical minerals kit. So we are basically a Teach for Teachers organisation. That's our aim. We want to sort of get the teachers' level of understanding of science up so they can actually introduce that into the classroom. We work Australia-wide. We also are STEM focused, so we are aware that geology does link into all the other sciences, biology via paleontology, chemistry via igneous rocks and so forth, and physics obviously through mantle dynamics. And we're also ACRA aligned. We mostly do professional development workshops where we come to your school, and there we basically spend either a whole day or an afternoon or a morning session, and we deliver between 2 to 3 PDs. We also do incursions as well on request. and we also do rock checks as well. I did a rock check at a school this week, and it's amazing how much asbestos I found. So it's incredible what's out there. So we do a lot of face-to-face PDs. We also do online PDs for free, which I'll talk about in a minute. And we also do field trips, as you can kind of see here. We got teachers here. That's the Warren Bungles down there. We had a field trip there about two years ago. That was very popular. For New South Wales teachers, we are NESA recognised PD provider. That means our PDs go towards your NESA hours. And we update our PDs pretty much all the time. So every single time we go to a new school, we kind of adjust our PD. So we basically talk about the geology of your area, and we also sort of make sure that any sort of adjustments to the curriculum are also included in the PDs as well. All our presenters are professional geoscientists. They either come from industry, from exploration, geology, from the renewable sector as well. We also got people from New South Wales Geological Survey. I'm an ex-academic, so I teach geology at University of New South Wales. So we're all sort of professionally trained, and we also have experience within the fields as well. And we also have some online and classroom resources as well. And so rather than, whoops, sorry, I've lost you guys there. Rather than basically say I'll go to the website, I'll just take the website to you. So here's our website, and what we have on here in our resources. We'll basically just talk about what we offer. So we offer a whole variety of PD workshops. We're now doing remote sensing and data science. That's really great for particularly New South Wales syllabus now has got a large data science section in there. And so our job is basically to show you where all the online resources are. There are so many online resources out there to do with remote sensing and data science that it's almost overwhelming. And we basically bring ideas to the classroom for you. We actually have worked exercises that we show in the PDs. We also do things such as obviously plate tectonics. We also have got a strong PD on climate change, and we sort of link that to paleontology. We also link that to the energy and energy transition as well. And also we have a seismology and earthquakes PD as well. We use a lot of the Geoscience Australia online tools. And again, we've got worked exercises in there as well. And teachers find these incredibly helpful. We also offer webinars. These are free. We offer them in term 2, 3, and 4. And as you can see in term 4, we're going to be doing riding the climate roller coaster, and we'll also be doing our place in space as well. So these covers topics within stage 4 and 5. So we tend to sort of teach between year 7 and year 10, but we also do primary school PDs as well, because in some of the curricula, a lot of the rocks and minerals has actually moved down into the primary school area as well. What else we do? Yes, we have TESEP events, so you can also go to Humanitix website and you can sort of work out where we're actually at, and you can just come and register. And here you can kind of see we're doing, I'll be there on the 10th of December in Grenfell, and we're doing, seismology and earthquakes and remote sensing there as well as introducing our rock kit, which is the next thing that I want to sort of show you as well. So we have a rock kit, which looks like this. So they're actually quite large. These are probably one of the better rock kits that you're going to get on the market. They're very, very large samples. They're all safe. They're all ready to use in class. They're actually good decent sizes as well. Each container contains sedimentary rocks, metamorphic rocks, igneous rocks. And they also come with a plate tectonics poster, which is a nice big A4 poster. Sorry, this one I use in class all the time, so it looks a bit battered. And the idea is that the rock kit is actually linked to the plate tectonics poster. So if you look on the website here, you can kind of see that we can't really see on there, but we've got all these little numbers along this sort of cross section of the Earth, and all those numbers relate back to the rocks. So you can actually sort of pick a rock out of the rock kit and then basically tell the whole story about the rock, how it forms, and the environment and where it formed as well. So it's got all the sedimentary environments in there, and also sort of like where the metamorphism is taking place, and where, of course, things such as volcanism is taking place as well. It's a great resource that we've got. And the other resource we have as well is the new critical minerals kit, which is two of these. One's for rock forming minerals and one's for the metallic minerals, which is basically the minerals that we're all using in our phones and technology in our lives. And these are also metallic minerals that break up. They come in nice little containers like that. It's a great resource to have as well in the classroom. So with our online resources, what we have is if we go to here, we can kind of see that we've got great sort of rendered images. These will also, we're going to be increasing the number of these that are available on the website. And you can show these in class rather than, sometimes you won't be able to see those minerals very clearly because, you might not have hand lenses in the class, but something like this will be great because you can just zoom in, spin it around and so forth. And also we've got a lot of information about rock forming minerals and all the different classes of minerals that there are there as well. So we've got a bit of a classification. The other resource we have as well are the rock and minerals kits. Sorry about this, guys. My computer crashed just before this. And what we have here, what comes with these, you buy this kit, or your school gets sponsored and you get a kit for free. We basically have these wonderful mineral stories. And what these are basically slides that you can use in class, and they tell us the story of each of these critical minerals. So in this case, chalcopyrite, which is the main ore for copper, we actually have a summary of that mineral, what it's used for and so forth. We also got a description and chemical composition of the mineral as well, and also the sort of streaks that it has, how hard it is and so forth. And then we tell the geological story of where it's found. And also we give us a little bit more further information about how these critical minerals are used and how much there are in Australia and where they mostly come from. We also have questions that go from year 6 to 10, where we basically give you a question and basically there's enough information within this slide to answer these questions as well. They're quite easy and they're quite fun. And also we show on the plate tectonics poster where, for instance, you might find chalcopyrite along the Earth's in the crust, also where it comes from in the mantle, and where it's forming in the crust and how it's extracted. And also we also have maps in here as well, which tell us where these resources come from and how much there is in Australia. The other thing that we're going to be having, what we're going to have soon as well, is that we're going to have the 3D renders for each one, and also we'll have the locality as well. So this is the resource that we offer at the moment. Also, if you want to book a PD at your school, it's very easy to do. You just basically give us your details and then send it off, and then we just get in contact with you, and then we'll organise a PD for your school. We get a lot of great feedback, and we also go quite far. So we've had someone this week go to Cloncurry in Queensland. I've been out to Lightning Ridge last month, and also we've got people pretty much going all around Australia. So it doesn't matter how remote you are, we'll come to you. That's about it, I think. Hopefully it wasn't too long.
No, that is wonderful. Thank you very much, Malta.
No, my pleasure.
I can speak firsthand for the quality of the PDs. We're excited to welcome back Phil in December to run some teacher professional development here in this space here with my floating arm. Thank you very much. We haven't heard from Jacoby, so what we might do is what we were going to do at the end anyway, and I'm actually going to reappear. Hello, I've just been off screen. We also had some tech issues, as you do, and our two cameras got reduced down to one. If you have any questions, please pop them in the Q&A, and I will read them out and we will pass around some of the time to answer those questions to all of us here. But I do have some canned questions ready to go. So I'll start with an easy one for everyone as well. Now, when we think of inspiring the next generation and continuing to show our passion and our love for the Earth and the Earth sciences, I'm wondering if you would pretty please share what got you into Earth science in the first place. Where did that passion come from?
Should I go first?
Yeah, go for it. Thank
Okay,
you.
I'll go first. Yeah. So I wasn't even taught geology at school, but our school had a major geology lab. So we did all our other sciences in that lab, and after class, I used to go through all the drawers and look at all the rocks, and then I discovered a whole heap of fossils, and it just blew my mind. So I wanted to become a paleontologist, and then what I did was that I worked out where all these fossils came from. And then on the first day that I was allowed to drive, when I had my L's, I just drove straight out to Narrabeen on Sydney's coast, on the northern beaches, and I started looking for Triassic fossils, plant fossils, and that was the best fun. And then just by looking and going around and collecting, I found a new biota of trilobites, which were all undescribed, and that was my
Really?
master's, and that was my
Wow.
how I got into paleontology.
Excellent. Great. Joe, do you want to jump in?
That's
Great.
exciting. I love it. So yeah, I'm a similar story, and I think that's one of the reasons why I'm so passionate about all of us working together on this support. I was schooled in Australia and really had very little earth science. So yeah, I had my aha moment when I was teaching. So I always loved my science, went down the biology, environmental science pathway into teaching. But it's when our school started to offer earth and environmental science that my boss said to me, "You're an environmental scientist, like give it a crack." And I very rapidly realized one, earth science is amazing, and two, wow, I've got a lot to learn. So I guess I've been in the shoes of so many teachers I'm so happy to work with now, where they, get the earth and environmental science class and go off, my background's marine science or chemistry or biology, or I'm not so sure. And it's a total pleasure to work with teachers and to see. Although it is very tricky for me, I've been doing this job for a lot of years now, and I get over the Christmas holidays, I quite often get photos of teachers we've worked with are now so hooked on earth science that they travel based on their earth science passion. So I get photos of people on, volcanoes or whatever. I hope you're having fun still working while I'm on holidays, Joe. But
Seeing the
it makes
beautiful
me so
world.
happy when people
Yeah.
find a passion.
I think to your point, Joe, what you said about people coming from different disciplines, geoscience and earth science is, and we like to push this narrative quite a bit as well, at the center. You got geophysics, you got geobiology, you got geochemistry. Geo is the common denominator across those three, more traditional siloed sciences, but there is something for everyone and something for every science within geoscience. Emily, do you want to share?
Yeah, that's a perfect segue. For myself and my journey, kind of came when I was in university, and that's kind of when the penny dropped when I realized the role of geoscience in all of these other aspects of science and how you really can follow any passion that you have. And the role that geoscience has in solving problems, like problems that we have as a society moving forward. And I think that just made me so excited that it's such an active area of research. And I think looking back on my school days, learning about geoscience, it was much more static, something that was just kind of in a textbook that was kind of fixed, and then learning about actually the research that's happening every day and that you can be part of that journey was really, really exciting. And for me, I think just listening to all of our presentations it's so exciting to see, I guess, the landscape that exists now, and all of those resources for teachers and for students to come into. Yeah, it's great.
Great. Um, I'll add a little bit more. I've spoken twice within the same question. I remember when I was at school, Earth and Environmental Science was offered, but I did not understand what it was. And this was back when I was a biology kid. And I ended up never actually doing biology because it was on the same line as visual arts. And even more a biology kid, I was an artist. Um, and then it wasn't until I got at uni, I got offered visual arts and ecology that I then went into science and I went into ecology. So then during uni, I did a couple of geoscience subjects and graduated with ecology, and then I found my way back to the earth sciences here, and I really enjoyed doing those subjects. And yeah, I think the cross-disciplinary applications of earth science and geoscience are great. Just a reminder, if you have any questions, please pop them in the chat or in the Q&A, whichever one you like. But I do have a second question. This is actually not one that I've written down, but based on the conversations that we've had, and I've kind of teased out some threads and a big thread, which all of us work towards, and especially in the schools that we legally have to work towards as well, the curriculum and the changes to the V9 with the national curriculum. So Geoscience Australia, we're a federal agency. We operate all over Australia, so we use the national curriculum. I'm wondering if Malta or Joe, you could talk about if you use the national curriculum for, the overall, again, direction setting of the work that you do, or Joe, you in New South Wales, you're in NT, you're in WA as well. What's the breakdown like?
Yeah, I might start this one then. So yeah, that is the challenge at the moment, right? And particularly the last, so V9 Australian curriculum, there's been even more sort of, I guess, splintering. There's been more difference between the different states and territories. So we're actually in the process of, so all of our resources were written to V8 and 8.4, whatever, of the Australian curriculum. At the moment, there's just a little bit of fiddling between where year levels belong, to be honest. So if you jump onto our website now, you might grab stuff that's in year 9 for year 8, or, et cetera, et cetera. But we're in the process of a reconfig, rejig update. And so we're planning for the website to basically go in for V9, but then also have searchable function, and we'll tag, particularly for places like WA and the NT, where teachers can pick up. And certainly, I'm aware we work with our school curriculum standards authority in WA, so there's some additional sort of stuff that's been placed into the curriculum. So we're just working to cover some of those, and it's more of that real world application stuff, which is really exciting. So I think the resources we're preparing to develop are going to be useful for everybody, but they're sort of explicitly stated only in WA. And, as Malta said, there's some differences around, going for depth studies and data sort of stuff in New South Wales. So the same thing, we're looking to enrich resources, knowing that they'll be useful to everybody, but they've ticked certain curriculum points for certain places. Yeah.
Great. Malta, you want to?
Yeah, so we basically work to the V9. In our webinars, definitely V9 for all our PDs that we do, it's all V9. However, in New South Wales, they've just changed the curriculum, and so they've added in data science. So what we've just done is we just wrote a PD for that. And so what we will do, we will happily change those PDs so they will match what the teachers need in each state or territory. And generally, because I mostly work in New South Wales, I'll just change it all to, it's basically every single PD that I give, it's aimed at the new syllabus that's coming in New South Wales. So we just gave a talk at one of the schools in Sydney, and they wanted to have something that's aimed at climate change based on that syllabus, and that I just went straight from the syllabus and made sure we went for every single dot point and gave that PD. And that PD will now be given as schools ask for them. So yeah, so we're very up on it.
Great. Excellent. Thank you very much. No questions in the chat. Do you have anything to add on that question? Or?
No, I think,
Okay.
yeah.
Wonderful. A reminder again, ask any questions you like in the chat, but I did have one pop into my head halfway through what you were talking about there, Malta, and I'll try and capture it again. You were talking about, in New South Wales, tailoring the teacher professional development sessions to, the individual groups and schools and things like that. And this is a question for everyone now. When teachers come to you, what can they receive in terms of like one-on-one, if there is one-on-one support or kind of, custom things for that school specifically, if they're having a really good insight into something in the curriculum that they just want a little bit of clarification on. Do you provide services like that as well?
Yes, we do. So that the last one that us did, where they got all the science teachers in, and they basically said, look, we want you to teach them this part of the curriculum, this part of the syllabus, and so that's what we did.
Great.
Yep.
Yeah. And from our perspective, yeah, the same. And our only caveat is, if you've got a little question, chuck it on email. I think our biggest problem is sometimes when teachers try to call us, the fun phone tag that is school hours and classes. Sorry, we certainly do. And I know that door's open sort of to anyone. Just contact us via the website. But I do know, particularly in that year 11 and 12 space, we do get a lot. And right down to the level of new teachers looking at their programs and suggesting resources to link into them, and that sort of level of mentoring and support. Absolutely.
Great.
Perfect. Just echoing, what's really been said as well at Geoscience Australia, more than welcome to contact us, send us an email, give us a call. We definitely offer lots of targeted, if you're going to come in for a visit, we can tailor your session to whatever you would like to cover. We can also deliver virtual sessions as well. That can either be using the resources that we have in the space, or also running through different data portals and things that we have access to here at Geoscience Australia. And so, yeah, if there's ever a point where you're having problems with a resource, or you have just a question, always more than welcome to reach out, and we'll help where we can. Yeah.
Great. I reckon that was wonderful. Thank you very much, everyone. I reckon we'll wrap it up there. Hopefully you have got something out of this session this afternoon. I've had a lot of fun. Big thank you to Joe, big thank you to Emily, big thank you to Malta and Karen as well for organising and running this whole day of Earth Science celebration. It's wonderful. Thank you.
Thank you.
Excellent. Thank you all for joining us, both in person and delivering our sessions, and everyone that's joined us from across Australia online. We will be sending a recording, so you can please share that with other teachers within your network as well. So many amazing resources and opportunities to connect with experts. It's definitely something that you want to share across your networks as well. And we'll send links to all of the websites that we spoke about as well. So thank you all so much. And yeah, that's a wrap for our Earth Science Week Virtual Excursions Festival. We've had, I think sort of over 650 registrations across our 6 events today. And several thousand students and teachers and parents joining us as well. So thank you all very much, and we will share all the recordings out probably tomorrow. So you will get a copy of everything, whether you were able to attend that session or not, that you can share again across your networks or with your students, however you like to use those resources. So thank you all very much again for joining us, and a big celebration for Earth Science Week. So thank you, everyone. It was absolutely wonderful to have you all here and to celebrate something that obviously is very close to all of our hearts. Have
Thanks
a
very
great
much.
afternoon.
Okay.
Bye, everyone.
Bye.
Thank you. All right, I'll head off.
Earth Science Week was proudly sponsored by Geoscience Australia and brought to you by Virtual Excursions Australia.